Hi, I'm Osman Chalimli.
I'm Corey Bloodstein.
And I'm Anthony Agresta.
And we're the Coffee Posse. And what we'd like to show you is the completed Coffee brand integrated coffee system.
Okay, so on the top here, top drawer, we have the Baron, the main microcontroller. It has a Freescale cold fire and a Freescale tower. A lot of Freescale going on here. It's running Freescale MQX, real-time embedded operating system, and a custom web server. It's also running the terminal driver for our lovely VT over here. And in addition to serving HTTP from the web server, we also support HTTP/CP, the up-and-coming coffee control protocol. So on the top of the Baron here, you can see we have these 4 coffee top ports. Each of those communicates with one of the 4 microcontrollers in the bottom drawer here, which Osman will talk about.
So the Baron has under its control 4 68HC12 microcontrollers, and each one is designated a task. By that I mean there's 4 of them, but only 2 of them are actually doing something at the moment. So we have, in clockwise order, starting from the red LED, Pot Sticker, Tank Man, Lumos, and Teabag. Now Lumos and Teabag are currently unoccupied, but maybe they will have a task to do someday. Pot Sticker is responsible for monitoring the status of the decanter and how much liquid and what temperature the liquid is in the decanter. Now, Tank Man is responsible for managing the water dispensing system which goes into the coffee maker. Essentially, both of these function independently from the Baron, and they can manage the task while the Baron is handling things such as the web client or the HTTP/CP server, possibly the terminal as well. Pot Sticker is managing ultrasonic sensors on the front, one of which is used to detect the presence of the decanter, the second of which is used to detect the fill level and is present on the read head. There's also an infrared temperature sensor, which is used to detect the liquid temperature. TankMan has 2 valves under its control and a micro switch, which is connected to a rubber duck in order to measure the fill level of the tank. Essentially, it will click when the tank has reached its full capacity. And then we use timing since it's a gravity feed in order to determine how much water has drained out of the tank. And there's a lot of different ways to communicate with the coffee maker. While we do have a couple buttons on the front, one of which is just simply to fill the pot up, we wanted to make it a little more friendly and allow the user multiple ways to both check on the coffee and brew a new pot.
So the local interface we have here is a VT220 terminal. In fact, we support 2 different terminal types. There's a switch on the front of the enclosure, which allows you to switch between VT-compatible and Hazeltine-compatible modes. We have here, in VT-compatible mode, a picture representing the current state of the coffee Baron, which will update automatically, as well as a limited text shell that allows access to all the same commands that are available on the web interface.
Along with the terminal interface, there are a web interface as well as a desktop and mobile client. The desktop and mobile client communicate with the Coffee Baron via HTTP/CP, which is Hypertext Coffee Pot Control Protocol. They let you check on the status of the coffee machine, that is, how much is in the pot, how hot it is, and how old it is. They let you request a read update from the coffee machine, and they let you request coffee by sending a brew request, either in discrete cups or a full pot of coffee.
What we'd like to do now is walk through a brew cycle. And we're just going to use water for this today, so we won't have to waste any grounds. And what we'll do is we'll start off, I'm just going to use the local brew button. But it's pretty much the same process remotely in any case. Now the read head will swing out and determine the fill level of the tank before doing anything else. This makes sure that whenever we do a fill request, we're not going to overfill the tank. If we request discrete cups, it'll cap up to that amount. So the head reads the fill level and then docks itself safely out of the way for water to flow through. In a second, it will send its results back to Pot Sticker, and then Pot Sticker will send its data to Baron, so it may determine how much water is going to be dispensed, and then request that amount from TankMan. TankMan will then open the release solenoid valve, which will begin to drain the intermediary tank. Once the tank begins draining, the rubber duck inside the tank will begin to lower down. We then use a time differential to calculate how much water has been dispensed, and then after that amount's been dispensed, the tank automatically refills.
Okay, so while it's brewing, I'd like to point out one other important feature. We have this brew mode switch here on the front. Right now it's in automatic mode. It's worth noting that if it were in manual mode, it would not be brewing right now. The arm would also never swing out. This way you can use the coffee maker in its original factory intended state. However, while it's in automatic mode, you get all of these nice automation features like automatically checking the fill level and temperature, and as you can see here, automatically brewing coffee.
After the brewing process is completed, the brewing waits a designated amount of time before swinging out the arm to reread the water level, just to ensure that no water gets on the read head, and that in case any cups of coffee were taken from the pot in the meantime, we'll actually know the fill level after the dispense. Is there anything else we need to address?
Not really. Unless you want to make it sing.